So welcome to Academia, and today we are going to talk about the second method of evaluating limits, which is factorization or difference of two squares. So for instance, you are told to evaluate the following limit. So limit as x approaches 2 of x squared minus 4 over x minus 2. So solution. So we are trying to solve this one. So you are going to get that on direct substitution, you are going to get it's 2 squared minus 4 over 2 minus 2, which then this gives 4 minus 4 over 2 minus 2. It gives us 0 over 0. So any number including 0 divided by 0, this is undefined. Even you put in your calculator, it's going to give us math error or indeterminate. All right. So in that case, we cannot, we proceed to evaluate the limit with a different method. All right. With a different method. So given that we've gotten that as indeterminate, we realize that we have a difference of, we can factorize, right? We can factorize this upper part, all right? So we know that x squared minus 4, this is the same as, it's a difference of two squares. We have this first squares minus two squared, something of that kind. Yeah? That's why it's called a difference of two squares. But the difference of two squares can be factorized into x plus 2 and x minus 2, something of that kind. Yeah? Right, of course, you can do the factorization and all that, and you'll easily get it, all right? So we can then rewrite this upper part. We can then, I'm just saying I'm getting a lot of noises. I don't know why. So then we can write this equation or our limit equation as follows. We can rewrite it as limit as x approaches 2 over x plus 2 x minus 2 over x minus 2, isn't it? Then in this case, what do? We can simplify this lower part, and this one is equal. So then now will remain as limit as x approaches 2 of x plus 2, which is equals now to 2 plus 2, which is equals to 4. So that is the answer. The answer is 4. So in that case, you just have to be careful, and sometimes you can use different methods to solve for these limits. All right. So you can. So let me give you another example, one that you will use to be able to get to use this method to solve, and then you are going to pause your video and see if you're getting the correct answer. So the exercise today is evaluate the following limit, and you have limit as x approaches 1 over x squared plus x minus 2 over x minus 1. So solve that one first, and then once you're done solving it, we are going to solve it together. All right, so I think you've solved it and you've gotten the answer, but still we are going to solve it together. So the solution. So the solution to this first, as usual, on direct substitution, what do you get? You get it's 1 plus 1 minus 2 over 1 minus 1. When 2 minus 2 over 0, you get 0 over 0. So this is undefined, all right? So then you proceed to the next method, okay? That is a factorization. Factorization, all right? So you get x squared plus x minus 2. So factorize this first part, isn't it? So, of course, this technique that will proceed from here is a common mathematics procedure that you want to get to factorize this one. So you're going to take the coefficient and this constant here, the coefficient of x squared and this constant, to give us a product, and the sum will be the coefficient of this x that is here. All right, so then that means here we have 1, isn't it? So product is 1 times minus 2, which is going to be minus 2, and the sum shall give us the coefficient of x, which is 1. So which two numbers have a product of minus 2 and a sum of 1? So if you think of those numbers, it's basically 2 and minus 1. So if you take 2 times minus 1, you're going to get minus 2, and if you take 2 plus minus 1, you're going to get 1. So these two can assist us in rewriting this equation, all right? This equation. So you just check which one can take the 1 and which one can take the 2. So this x here, we are going to split it using these values. So then you are going to have x squared, all right, plus, okay, I think we'll have minus x plus 2x minus 2, something of that kind, yeah? And then now we can put brackets such that we have it as, we can take x outside here, and we have x minus 1, isn't it? Plus in this side, we are going to take 2, and you're going to get x minus 1, all right? So because this is a repeated factor, you're going to have x plus 2, okay, x minus 1, isn't it? So then that means you can write this equation here for the limit as this, as x plus 2, x plus 1 over, no, x minus 1, I mean, sorry, this is minus, over x minus 1. In this case, x minus 1 and x minus 1 are going to go, and you're going to have limit with, when you replace here with 1, you're going to get 1 plus 2, which is 3. So the answer to that question is 3. So if you've gotten that answer, that is good for you. If you've not gotten it, then you have to do some work so that maybe you don't get it wrong next time. So I'm going to give us another example on direct substitution so that we are able to solve this method in an easy way. So let us try and solve this equation on factorization. So I'll just have to use this part here. So the question says evaluate the following limit. Evaluate the following limit, and you're given limit as x approaches, the question is limit as x approaches minus 1 over 2x squared minus x minus 3 over x plus 1. So evaluate this limit. So solve it, pause the video, solve it, and tell me what the answer is. Then you are going to solve it together. So thank you. I know you solved this equation. So now you are going to solve it together. So then we'll say on direct substitution, what do we get? We get minus 1 squared. So this is 2 minus 1 minus 1 minus 3, isn't it? So what do we get here? You're going to get it's 2 plus minus and minus, this one's going to be a positive, yeah? 3 minus 3 over minus 1 plus 1. So this is 0 over 0. This is indeterminate, isn't it? So this method has failed. So, but when you look at this one is a quadratic function. So we can try to see if we can split it or factorize it, all right? So we have 2x squared minus x minus 3. As I said, The product must be the coefficient of x squared and this constant, yeah? So product here must give us what? Product must be 2 times minus 3, which is minus 6, and the sum is minus 1. So which two numbers are going to give us a product of minus 6 and a sum of minus 1? A product of minus 6 and a sum of minus 1. So which one? What do you think? So if I think it's minus 3 and 2. So it's minus 3 and 2. If you take the product minus 3 and 2, you get minus 6. If you take the sum, minus 3 plus 2, you get minus 1. So these are the way we can use to factorize it. So then that means we can write this equation here, okay? This, we are rewriting it here as 2x squared minus, so it will be plus 2x, isn't it? Minus 3x minus 3 now, all right? Then now you can factorize. We can take x outside and 2. Actually, you can take 2x outside. So then we remain with x, isn't it? Plus 1, isn't it? Then here we can take 3 outside. And then because of this minus, this is going to be x. It's going to be x plus 1. Not plus 3, plus 1. So then here we're going to have 2x minus 3 into brackets x plus 1, isn't it? So something of that kind. So this is how this one can be factorized. So this one, that means we can write this as 2x minus 3 x plus 1 over x plus 1. And because these are similar, we are able to cancel this, isn't it? Yeah, we are able to cancel that. And then we remain with the question written as, I'll write it here, as limit as x approaches minus 1 over 2x minus 3. So when you substitute minus here, we're going to have minus 2 minus 3, which you're going to get the answers minus 5. So if you got your answers minus 5, you're good to go. And that is all that we've covered today about factorization. In the next lesson, we are going to talk about another method of evaluating limits, which I think it's going to be, if I can see which method can come first, is evaluating limits through rationalization. So we shall use rationalization to evaluate limits in the next video.